Hi, this is IDD 225 Probability and Statistics for Digital Analytics. Today we are in lecture 11, Null Hypothesis and P-value. So last time we talked about confidence interval, how we can use the normal distribution and use that to estimate the population mean using the sample mean that we got. Now we are going to apply that furthermore. The idea is pretty similar to estimation, but now we are going to use the normal distribution and all the math stuff to help us make some meaningful decision. So let's start with a brief summary from what we have done so far. So it is the goal of this course to understand what this flowchart is about. Starting from doing the sample, I get some stuff and use the descriptive statistics to get some meaningful information out of the raw data that you get. Just a bunch of data. How can you turn that into something that is easier to read using graph, and so get some nice information or nice statistics such as the mean, the standard deviation, variance, and other stuff. And now we are going to say how can we apply that into actually making a decision. So last time it's about the top part, which is the estimation, and today we are going to study the bottom part, the hypothesis testing. So here's a brief outline. So we are going to have 3 topics. First, the null hypothesis, of course. Then we are going to talk about the type 1 and type 2 errors, and how can we avoid or at least how to minimize those errors. And lastly, what is the concept of the p-value? The actual the hardcore, not hardcore, the actual math is going to be in the next week, but let's discuss some concepts of why we have to perform all these steps. So let's start with the null hypothesis. Now, in the word hypothesis, you should be familiar with that if you are science students. So the hypothesis is something that we believe to be true. It's something that we have to start with before we can do experiment or perform some scientific stuff. But now we have another word now. And this null hypothesis is what we use in statistics. So let's first you can actually look at this clip. They have nice animation, nice explanation, all those stuff. So if you learn from that, then I'm not gonna blame you on anything. I'm more than happy if you just keep this lecture and watch it. But yeah, for now let's say if you want to do some math, see some examples how you actually compute the p-values and other stuff, then you can stick around. So next we're gonna talk about this definition of the null hypothesis. And so the null hypothesis is an assertion, or something that you believe to be true in the first place. And that assertion is about the population parameter. If you remember last time, parameter is the values that we don't know yet. It's the mu, the average, the proportion, the variance, and so on and so forth. And now we are talking about the population, and so that's unknown, that's hidden somewhere. What we can do is we can use the sample parameters to estimate the population parameters. But since we have to estimate, like we don't know yet, so we have to have some idea or some starting point. And so let's say we believe that this parameter is some value, and that value is expressed as a statement, and that statement is either the equation or inequality, and so etc. Usually we focus on this too because this is where we can do the math, and that's gonna be easier to understand. But we can do more with it. And so we assert something, like that's a p. If you see an example in a moment, but you may ask what is h now, and that's the null hypothesis. H stands for the hypothesis, and the 0 is the null. So this is actually the null here has the meaning that this curve like this is the hypothesis. If you haven't done anything, if starting from scratch, let's say you get some sample. Actually, this needs to happen before you gather the evidence. It's the hypothesis that we get from zero knowledge, it's from nothing. Maybe it's from somewhere else, but that has to be the starting point. And so that's where the word now comes from. And once we have the null hypothesis, something that we believe to be true, we must have the opposite. It's kind of like if our belief were false, then the other part, the opposite, would be true instead. And that is called the alternative hypothesis. Maybe it's easier to think of it as the opposite. The actual keyword is alternative. And so it's the negation. The negation is mean you just put the word not in front of the statement. And we write it as H1 and colon and the sentence, and this is the negation. And there are two ways to write. I prefer one because we have 0, and the opposite of 0 it's not 1, but it's kind of the same thing. I mean the same symbols. But sometimes you might see the letter A instead, and that A stands for alternative. So this is fine, but for this lecture I'm gonna stick with H1. And sometimes, as you can see, if you know P, then you can put the word not in the sentence to make it a negation. So most of the time we can just state H now, and H1 or the alternative is kind of implied. So let's for example, for instance, so we may assert, we may believe the following hypothesis. But it should be I because it's just a single hypothesis. So we believe that mu is greater than or equals to 100. Maybe I'll zoom it in a little bit. Yeah. This is what we believe. And so it means we believe the average is at least 100. The average of what? Of what you are, what you are, working on, what you are trying to prove or disprove. And so maybe you say, maybe you are a company and you produce stuff, and you want to make sure that the customers get quality products. So you claim, you assert that okay, if you buy the stuff from our company, you're gonna get at least 100 good things. Or maybe you guarantee them that it's has this bag of, let's say, candies has at least 100 candies. So that's your claim. Like on average, it should have at least 100. And that's how we believe. Then you can assert the alternative hypothesis. If I believe it has at least 100, then if my statement or if my assertion is wrong, then it means the average is less than. You mean it is not greater than, so it means it's implied that it's less than 100. So that's the H1 or the hypothesis, the alternative hypothesis. Oh, in other words, that's a typo. So that's one way to just to make a null hypothesis. You can make it a null hypothesis in different formats. You can say that okay, we believe that the proportion or the ratio is less than 0.4. Again, maybe let's say that if you buy a bag of candies, you get less than 40%, less than 40% of the candies in the bag. It's gonna be a chocolate something. And that works too. And the alternative hypothesis for this null hypothesis would be that P is actually greater than or equals to 0.4. Okay, or you can say, okay, I believe that the variance, the standard deviation of this data point is equals to 0.2. And of course, you can claim that's a strong claim, as you can see, because instead of allowing for a range, then I claim that it is exactly 0.2. Which, let me add a remark here. This actually implies that we believe that it is close to. It's not going to be 0.2, of course, but that means we believe it is 0.2 plus or minus. So the alternative would be that this is, it's a colon. It is not 0.2. The alternative hypothesis is that the standard deviation is not 0.2. And so that's the hypothesis that we have to start with. And okay, let's see more examples here. So Suppose that there is yeah, that's the same example from last time. We have a machine that fills 2-liter bottles with cola, and so the company claims that the average is at least 2,000 liters or centimeters cubes. So if you want to transform that into a null hypothesis, simply say now is that. So you have to scan for the keyword. What is this question is about? It is about the average. Okay, so it's about average. So we believe that the population mean, the population average is at least 2,000. And that's what you want to start with. You believe that, and then you want to maybe disprove that statement. And sometimes you might have to add the alternative hypothesis, just for the record, that okay, it is less than 2,000. So that's the claim. And so I believe it is 2,000. Then the question is, so suppose that I doubt, right? That doesn't seem like the right claim. So I buy a bottle of soda from some place, and then I measure the volume, and I got 1,999. The question is, does it mean the claim is false? Can I immediately conclude that the claim is false? And the answer is it depends. Of course, you want to say, oh, look at this one. This one is one single counterexample, so your claim must be false, right? But if you remember from what we have done so far, even though the machine that is pretty precise on the volume of soda that it using the bottle, we're gonna always have this kind of curve, right? Even though we know that the average is 2,000, and then sometimes yes, maybe some small chance, and maybe the thing that fills soda is kind of slightly off the center, so the soda spills out a little. So sometimes it's gonna get a little bit smaller. Sometimes it's gonna be a little bit higher. We don't know yet, but based on this information, based on this hypothesis, we believe it's the green curve, and there are some small errors. And so we cannot just say the claim is false immediately. And the question is, what can we say about the claim? Maybe from 1,999, you say it seems close enough that we can just, okay, you can just say that, okay, this is just one tiny error. Don't worry about that bottle. Okay, so that means one single sample is not enough. That means we have to collect more samples. Maybe next one is 1,002 centimeters, and so you say, oh, okay, and that means maybe the previous one was just a little error. Maybe the next one you got 1,995, and you say, oh, now that's 5 centimeters cube smaller than the claim. But then again, yeah, you can't be sure yet. And so once you get once you get enough samples, we can get the average. Now this is where we call the sample mean. And let's say sample mean is 1,998. Let's just say we have enough money to buy 50 bottles. So based on those 50 bottles, we get the average of 1,998. Then, what can you say about the claim, the actual claim? And we still say that the claim is false? The answer is again not quite, because even though 50 seems like a lot, maybe we are just unlucky. Maybe if we let other people repeat the same experiment, by bottles, measure them and find the average, then maybe they get like 100 other people will get 2005, and maybe we are just the unlucky group. So we can't say that yet. But the question is, what can we say about that? And the answer is this whole lecture. And so we're gonna have to find, before we got the sample, before we get the sample mean, we have to, starting from this hypothesis, we have to say to ourselves, right, we have to have a decision policy. So if you believe it is at least 1,000, so we must have to say beforehand that, okay, if it is 1,098 or higher, then we can still believe the claim. Once again, maybe you must allow for some error. And if it is less than 1,098, then we reject and we call that company out. So this is what we have to settle beforehand. Based on the claim, we have to have a policy. We have to have a cutoff with which values or which version of this number is gonna be convincing enough that we will still believe what we have assumed in the first place, or which kind of evidence should be convincing enough that we gonna reject the claim. So once we have this screen, then we can collect samples for the sample means, and then use that number and compare that to what we have in the first place, the policy that we settle. And so that's the goal of this hypothesis, of this null hypothesis. And now we are going to go into the math part, where we ask then how can we know how if it says it's 2,000, like which number should be the cutoff, which number should be the right amount of so that is convincing enough that the claim is true or false. So let's take a look at another example of how to set up the null hypothesis. So we want to test whether the mean GPA of the students in American colleges is different from 2.0 or of 4.0. Let's set the null and alternative hypothesis. So in these questions, you can see, first find the keyword. What kind of parameter that we are dealing with? We are dealing with the mean. You may say that, okay, it's the mean of the average. Which one is the mean? So which one is kind of like the meta mean? Like we have a mean of a single student, and we have the mean of all those means. But nevertheless, eventually we are dealing with the mean. And so what's the claim? Like we want to know whether the average is different from 2.0. And again, that's kind of still not clear from the sentence, which could be good or bad depending on how you interpret it. But if you want to test whether it is different, then let's say we believe. Well, since it is whether, so there are two outcomes. Like we might believe in that statement, or we might believe in the alternative, or the negation of that statement. So let's say we believe that it is 2.0. If that's what we believe, is that what we assert, then we will say that we believe that the average is equals to 2.0, or just 2. And let's make it 2. And then of course the alternative is the negation. If you believe it is 2, then the alternative is that it is not 2. And that can be expressed as the inequality sign. And so that's all for the null and alternative hypothesis. But on the other hand, you might read this sentence and you interpret, okay, maybe we believe that it is not 2.0. And again, that's fine too. You can make any kind of hypothesis you want. You should believe it is not 2.0. Then your null hypothesis would be that the population mean is not 2. And then the alternative would be that the average is 2. And so as of this works, but eventually they're gonna give you different results based on the actual sample. Right, so that's Oh, yeah, that's the first concept of the null hypothesis. Let's see why we have to do all these things.